Okay, this kind of a map is well and fine. It shows us what we need to see. But frankly, all of these lines turn into a big complicated mess. It's really hard to kind of keep track of where you're going and which allele is coming from which parent and making sure they're mixed and combined right. It just makes a mess. So let's simplify things. We can simplify things with something called a Punnett square. Basically, we draw a square and then we split it in half twice. Okay, so it kind of looks like a window like that. Now, in order to create a Punnett square, we take the alleles from one parent and put them on one side, and the alleles from the other parent and put them on the other side. Now remember, we were breeding for our narrow-bodied mandrake plants. So our mom mandrake had little b, our dad mandrake had little b. We determined that F1 generation, all the offspring from mom and dad, F1, would equal little b, right? Let's see if the Punnett square agrees with us. So what we do is we take the alleles from the mom. She has two, one little b here, one little b here. We put them up here, little b. This will be our mom. It does not matter if I put mom here or here. Doesn't matter. You can put her wherever you want, as long as the other parent is on the other side. So that's going to be dad. He's going to be over here. Dad's alleles, again, little b. Now it makes it really easy to combine all of these alleles and figure out what the F1 generation, the offspring, are going to be. All right, so little b. So you drop it down. Drop this little b down, bring this little b across. Okay, so this box represents these two. This box is going to represent this one and this one. This box is going to represent this allele and this allele. This box is going to represent this allele and this allele. Okay? So every time you're putting one allele in, again, let me kind of show you how this works. Let me make it a little bit bigger, because it's really important that you know how to draw these right. Okay, let's put mom over here this time, and we'll put dad up here. Again, we split the alleles. He has two. He has little b. One b here, one b here. We split mom's alleles, one in each window, one here, and then we start combining them. This box is a combination of these two alleles. This box is a combination of this allele and this allele. So you carry this one across, bring this one down. This box is a combination of this mom's allele here, dad's allele here. This box, a combination of this allele over here from mom and this allele down from dad. All of these babies, all of this offspring is our F1 generation. Okay? They all have a genotype, little b. They all have a phenotype, narrow-bodied mandrake plant. Okay? Now, Mendel went back and took his F1 generation pea plants and he bred them together. Now, he had his purples in there. They were the dominant. Remember, those were the ones that showed up most often. Well, when we're dealing with these mandrakes, we're dealing with the recessive trait. We're dealing with the one that didn't show up as often, the narrow-bodied. Okay? So when we do that, if I were to take two of these F1 generations, remember they all had B and B. So here's an F1 female and an F2 male. And remember, these, again, were their phenotypes. I go back and breed them. I'm going to get the same thing again. Okay? So the F2 generation will also be all narrow-bodied. This is why when Mendel took the white flowers, which were the recessive trait flowers, just like the narrow-bodied mandrakes are recessive mandrakes, he always got white every time because there was no dominant allele showing up. Okay? As long as you don't have a big B, you're not going to get a wide-bodied mandrake. And if you're breeding a narrow body to a narrow body, as we know from last week, if you have a recessive trait, there's only one possible genotype, and that's little letter every time. You'll never have a dominant allele show, so none of the offspring will ever have that dominant trait. We'd never have a wide-bodied mandrake, no matter how many times we bred all of these together. Okay. Oh yeah, that was it.